Hi, so today we are going to learn lesson 6.6, which is image formation by spherical. Spherical mirrors are part of a sphere that has been cut. There are two types of mirror. From here, we need to introduce the two curves of mirror that is not related to the plane mirror. So the first diagram is a concave mirror. The second one, the surface also reflected to the light, but we can see the shape that is a reverse with the concave, and it is called as a convex mirror. If the inner surface of the part has been cut reflects light, the mirror is a concave mirror. If the outer surface of the part that has been cut reflects light, the mirror is a convex mirror. Concave surface and convex surface of a steel spoon act as concave mirror and convex mirror respectively. So this one we can try. After that, we can find out what happened for the image. So from the concave surface, we can find it that our image is a reverse and we can call it as an inverted. Another one is a convex. We can find the image still the same, which is upright, but the size become more focused. Then we will go more detail. First one is a plane mirror. Plane mirror, we can find it as a narrow field vision and the angle should be the fixed one. That means the wider area we cannot see. The next diagram is the concave mirror. Concave mirror is a very narrow field of vision compared to the plane mirror, but one of the advantages is they can focus the image. So maybe we can see the image become very large because they cannot focus to the other area. They just can focus near image, so we can find the image become large and clear. And the last diagram is a convex mirror. Convex mirror can view wider field of vision, but the disadvantages is the image form will be small. So this one is the differences between the three types of mirror, as they produce the image with the different characteristics. Okay, now we need to find out the red diagram when the light just pass. After that, they will go to reflected. But how will they reflect? So the first one is a concave mirror. All the light are parallel. The light will reflect to the focal part. The capital F, we call it as a focal part. All the light will converging to another part from F. So from here, we can find the image will be very large because they focus to one point only. Then we can find the small f. Small f means focal length and small r we call it as radius. Then we go to the convex mirror. All the parallel light will go. After that, they will refracted from f. Concave mirror is refracted to the f, but convex mirror is refracted from f. After go to f, they will diverging. So we will find out the arrow. They will go to wider area. They can see the wider area, but the image is not clear because they already spread out.
Next is guide to drawing spherical mirror ray diagram. Concave mirror. Light ray passing through C is reflected back to its original path. Then light ray parallel to principal axis is reflected to the focal point F. Light ray passing through F is reflected parallel to the principal axis. Next is convex mirror. Light ray traveling towards C is reflected back to its original path. Light ray parallel to principal axis is reflected as if it originates from the focal point F. And light ray traveling towards F is reflected parallel to the principal axis. Positions and characteristic of image by a concave mirror. Object position, object at infinity, image position, in front of mirror, characteristic of image, real inverted diminish. Object beyond C, in front of mirror, real inverted diminish. Object at C, in front of mirror, real inverted same size as object. Object between F and C, in front of mirror, real inverted magnified. Object at F, image at infinity, behind mirror, virtual, upright and magnified. Object between F and P, behind mirror, virtual, upright and magnified. Position and characteristic of image by convex mirror. Object position, object beyond F, image position behind mirror, characteristic of image, virtual, upright and diminished. Object between F and P, behind mirror, virtual, upright and diminished.
Now we are going to talk about the applications of concave mirror and convex mirror in daily life. The first one is cosmetic mirrors. A concave mirror is used as a cosmetic mirror to produce a magnified image for a plant. The next one is dental mirror. Dental mirror forms an upright and magnified image to examine the teeth. The third one is reflector in car headlight. A parabolic concave mirror is used as a reflector in car headlights to maintain light intensity even at a distance. The fourth one is head mirror. A concave mirror is used by ENT specialists to be put on the patient's forehead during surgery. Light rays refracted by concave mirror can focus on the nose, ear, and throat of the patient, making the infected part more visible. The next one is astronomical telescope. Light enters the telescope at the right and travels to a concave mirror. The light is then reflected back to a smaller second convex mirror. The light is then reflected back again out of the back of the telescope to the eyepiece and the eye. The last one is solar furnace. Large concave mirrors are used to focus sunlight to produce heat in the solar furnace. They are also used in solar ovens to collect a large amount of solar energy in the focus of concave mirror for heating, cooking, melting metals, and more. Now it's applications of convex mirrors in daily life. The first one is blind spot mirror. Blind spot mirror is a convex mirror placed at sharp corners to widen the field of vision of the driver. The next one is security mirror in buildings. Convex mirrors are used in buildings or shopping centers for surveillance purpose. The next one is sunglasses. The convex mirror reflects the sunlight away from the person's eye wearing the sunglasses. The fourth one is vehicle rear mirror. Vehicle rear mirror provide a wide field of vision to enable drivers to see vehicles coming from behind. The fifth one is magnifying glass. Convex mirrors are widely used for making magnifying glasses. In order to make a magnifying glass, two convex mirrors are placed back to back. The last one is street light. Since the convex mirror has the property to diverge light, it is used as a reflector in street lights so that it could spread the light to larger areas. Now we'll move on to the exercises. Question 1. Figure 6.47 shows a pupil looking in the direction of a plane mirror and a convex mirror of the same size. A. Complete the path of light for both types of mirrors. B. Which type of mirror can produce a wider field of vision? You may pause the video to complete the questions. These are the answers for A and B. Question 2. Diagram A and Diagram B shows the image form of a vase of flower when it is placed in front of mirror P and mirror Q respectively. A. State the characteristics of image formed by mirror P and mirror Q. B. Identify the type of mirror used. Give one reason for your answer. You may pause the video for a while to complete the questions. Now I'll show the answers. A. The image form is virtual, upright and same size for mirror P. The image formed by mirror Q is virtual, upright and magnified. B. The type of mirror used by mirror P is plane mirror. This is because the image is same as the object. The mirror used by mirror P is concave mirror. This is because the image is magnified.